So in this video, we're going to be looking at product of prime factors. We're going to be looking at what product of prime factors are. Then we're going to look at, well, how do you find the product of primes of simple numbers like this, slightly more difficult numbers like these ones, and then finally, how can you use that to find the HCF and LCM? So the way my videos work, I'm going to do the example on the left, which is I do. You're then going to press pause and I've got the example on the right, which is you do. So firstly, what are products of prime factors? Product just means to multiply, and prime numbers are numbers, any number that is greater than 1 that has 2 factors. So what does that mean? So for example, 2 is a prime number, 3 is a prime number, 4 is not a prime number, 5 is a prime number, 6 is not a prime number, and 7 is a prime number. So you're probably wondering, well, how do you know if it's prime? So any number greater than 1 that has 2 factors. So this has 2 factors. It's divisible by itself and it's divisible by 1. 3 is divisible by itself and 1. 4 is divisible by itself and 1. However, it's also divisible by 2. That is why it's not a prime number. So same with 5. 5 is divisible by itself and 1. Now 6 is divisible by itself, 1 and 3 and 2. And 7 is divisible by itself and 1. So hey, there you go. So hopefully now you know what prime numbers are. So any number greater than 1 with 2 factors. So how do you find the product of primes of 20? So you're going to look for 2 numbers that you multiply together to give you 20. So we can go with 2 and 10. Now, if it's a prime number, you circle it. So 2 is a prime number, we'll circle it. Now, 2 numbers that times together to give us 10. That's 2 and 5. Again, if it's a prime number, circle it. So the product of primes of 20 are 2 times 2 times 5. We can write that as powers as 2 squared times 5. Now, press pause and have a go at the example on the right. So hopefully you've had a go at this one. So that's going to be 3 times 10. 3 is a prime number, I'll circle it. That will be 2 times 5. So in this case, our answer is 2 times 3 times 5. So picking another example, we've got 100 now. So we can go with 10 times 10. Now neither of these are prime numbers. So 10 can be broken down into 2 and 5. Both of these are prime numbers, and this can be broken down into 2 and 5. So that means the product of primes of 100 are 2 times 2 times 5 times 5. Which you can write in indices as 2 squared times 5 squared. So again, hopefully you've pressed pause and had a go at the example on the right. So that can be 4 times 3, where 3 is prime, and the 4 can be broken down into that. So that gives us 2 squared times 3, or you can write 2 times 2 times 3. So moving on, this can be written as 9 times 2. 2 is prime. 9 can be broken down into 3 and 3. So as product of primes, this is going to be 2 times 3 squared. Again, hopefully you've pressed pause and had a go at this one. There's many ways you can break it down, but I'm going to go with 6 times 6. Now, neither of them are prime, so that's going to be 3 times 2 and 3 times 2 on this side, which gives me 2 squared times 3 squared. Again, you can write that as 2 times 2 times 3 times 3. Now we're going to look at slightly harder examples, as the slide says. So now we have 5, 2, 5. Now with this, you can see that it's going to go in the 5 times table. So I can see that 5 times 5 is 25. So I can go with 5. 5 times 5 is 25, and there's a 5 here, so that's going to be a 1 there. So the 5 is prime. I can circle that. This can be broken into 5 times 3. Those are both primes, so this can be written as 3 times 5 squared. So hopefully you've pressed pause and had a go at the example on the right. So for 720, you can break it down into 10 times 72. Now the 10 can be broken down into 2 times 5. And the 72 can be broken down into 8 times 9. Now neither of them are prime, so we can break that down further into 3 times 3. And the 8 can be broken down into 4 times 2. 2 is prime, and we can break the 4 down into 2 and 2. So there's quite a lot going on there. So they are 1, 2, 3, 4 2s. So that's going to be 2 to the power of 4. They are 2 3s, and there is 1 5. So that is how you write that as a product of its prime. Moving on to this one, we have 4, 8, 6. Now it's a prime number, so a little hint. Sorry, it's an even number. If it's an even number, you can divide it by 2. So we can do 2 times. Well, if I half 6, I get 3. If I half 8, I get 4. If I half 4, I get 2. So that becomes 2, 4, 3. Circle that as its prime. Now with this, it's not an even number, but I can see it goes into the 3 times table, because 3 times 1 is 3, and 3 times 8 is 24. And now the 81 can be broken down into 9 times 9, and the 9 can be broken down into 3, 3, 3, 3. Let me just tidy that up a bit. And circle the prime numbers. So we have 5 3s and 1 2. I normally tend to write it from smaller to bigger, but you can write it either way around. You can write 3 to the power of 5 times 2. That's fine as well. So hopefully you've pressed pause and had a go at the example on the right. So with this one again, I don't know what timetable it goes into, but it's an even number, so I can always just half it. Half of 500 is 250. Add 2 on for the 4, so that's 252. Again, I can half this again. It's an even number, so that's going to become 126. And now I can see this goes into the 3 times table, because 3 times 2 is 6, and 3 times 4 is 12. And that can be broken down into 7 times 6, and that can be broken down into 3 times 2. So we are then left with 2 to the power of 3 times 3 squared times 7 as a product of its primes. So 360, I can break that down into 10 and 36. That I can break into 6 and 6, which becomes 3 and 2, 3 and 2. And the 10 can be broken down into 5 and 2. So there we go, there's all the prime numbers, so that becomes 2 to the power of 3 times 2, 3 to the power of 2 times 5. So hopefully you've pressed pause and had a go at the example on the right. So again, it looks like quite a tricky one, but I can start to see that all of these numbers go into the 3 times table. So 3 times 2 is 6, 3 times 3 is 9, and 3 times 4 is 12. And now all of a sudden you have an even number again. So with this even number, it doesn't look like it goes to the 3 times table. So we can just go with 2. Half of 400 is 200. Half of 32 is 16. So that's 216. 216 is an even number. We can go 2. Half of 200 is 100. Half of 16 is 8. And then we're left with 12 times 9. And now the 9 becomes a 3 and 3. And the 12 becomes a 4 and a 3. And the 4 becomes a 2 and a 2. So our answer for this, how many 2s have we got? It looks like we have got 4 2s, and we have got 1, 2, 3, 4 3s. So that is our answer there. Now, moving on, we can also use product of primes to find the LCM and HCM. Now, this is quite a common exam question. After they've asked you to find the product of primes, they can ask you to use that to find the HCF and LCM. So firstly, what is LCM and what is HCF? So at the bottom here, LCM of 24 and 40, the way you do that is you list out all the multiples of 24, the multiples of 40, and you find the lowest common one. So in this case, the lowest common multiple is 120. And to find the highest common factor of 24 and 40, list out all the factors of 24. So that's starting at 1 all the way to 24. Do the same with 40. Now, if you look at the highest common factor, so we can see 2 and 2 are common, but that's not the highest. The highest is 8. So the HCF is 8. And the LCM is 120. Now, you can do it this way, which is quite manual, and it can be tricky to do this for really big numbers. The other way you can do it is using product of primes. Now, so once you found the product of primes using the factor tree of 24, I'm not going to do that here because I think we've got enough practice now, but I'll tell you what the answer would be. So when you find the product of primes of 24, you probably don't want to list them out as powers because it makes your life easier in this case to not do so. And if you find the product of primes of 40, that's what you get. Okay, so now how do you use that to find the HCF? Now, what you need to do is find matching pairs. What do I mean by that? So this 2 matches with this 2, this 2 matches with this 2, and this 2 matches with this 2. So the HCF is going to be all the pairs multiplied together. So there's 1, 2, 3 pairs all together. So if I do 2 times 2, that is 4. 4 times 2 is 8. So hopefully you can see how I've used products of primes to find the HCF. And how do you find the LCM? Well, you take the HCF, which we got as 8, and you multiply it by all the remaining numbers. So the remaining numbers in this case are 3 and 5. So I'm going to multiply the HCF by 3 and 5. You know, 3 times 5 is 15. 15 times 8 gives us 120. And again, hopefully, you can see how I've used this to find the LCM and how I've used it to find the HCF. So that is how you can use product of primes. Now, the example on the right is what I want you to have a go at, but we've already calculated this on the last slide, so you can just rewind the video a bit to get the product of primes for these two and have a go at that. So hopefully you had a go at this. So the first thing you do is list out the product of primes, which you can find either by rewinding the video to the last example or by mapping out the factor tree. So again, like I said, we're not going to write them out as powers because it makes our life easier to list them out like this. So that's the product of primes for 360. And for 1296, we had 4 of these. So as usual, for the HCF, we're going to find the matching pairs. So 2 and 2 match, this 2 and this 2 matches, this 2 and this 2 matches. Now that 2 doesn't match with anything. Moving on, this 3 and this 3 matches, and this 3 and this 3 matches. So now that we've got the matching pairs, we're going to write each pair out once. So if you do 2 times 2, that's 4. 4 times 2 is 8. And then if you do 8 times 9, that will give you 72. So that's the HCF. And to find the LCM, we're going to take that HCF that we found, which is 72, and we're going to multiply that by all the remaining numbers. So in this case, the remaining numbers are 5, 2, 3, 3. So we're going to do 2 times 3 times 3 times 5, and that gives us the LCM as 6,480. And you can see if we had to do this using this manual approach, that would have taken us a very long time. So this is how you can find the HCF and LCM using the product of primes. Now moving on to the next example. Again here, I'm not going to draw out the factor tree because I think we've got enough practice now on how to find the product of primes. So I'm going to tell you exactly what the product of primes are here. So for 120, it would be 2 times 2 times 2 times 3 times 5. And for 150, it's going to be 2 times 3 times 5 times 5. And the HCF, we're going to find the matching pairs. And 5. So that's going to be 2 times 3 times 5. 2 times 3 is 6. 6 times 5 is 30. So that's your HCF. And for your LCM, that's going to be your HCF times all the remaining numbers. So if I just get my green highlighter, so that's going to be all of them there. So that is going to be 2 times 2 times 5. So we know 2 times 2 is 4. 4 times 5 is 20. 20 times 30 is 600. So press pause and have a go at the example on the right. When you're ready, press play for the answer. So hopefully you started by finding the product of primes, and you found them to be 2 times 2 times 2 times 3, and 2 times 2 times 3 times 3 times 3. And the HCF is the matching pairs. So the matching pairs in this case are 2 and 2, 4 and 4, 3 and 3. That looks to me like it's 12. So that's 2 times 2 times 2 times 3, which is equal to 12. And the LCM is simply going to be 12 times all the remaining numbers. That's going to be 2, 3, 3. And that becomes 216. So moving on to the next one, you now have 84 and 35. So we're going to start with listing out the product of primes. So for 35, it's nice and easy. That's just going to be 5 times 7. For 84, we have 2 times 2 times 3 times 7. Now the HCF here is going to be the common pairs multiplied together. So the common pairs here are 7. So this is just going to be 7. And the LCM is going to be the HCF, which is 7 times all the remaining numbers. I should probably be a bit more consistent with the colors I'm using, so just so it's not confusing. So that's the HCF. And for the LCM, we're going to multiply everything else together. So that's all the green stuff. So if I just change over to the green pen, times 5 times 2 times 2 times 3. That gives us 420. So press pause and have a go at the example on the right. When you're ready, press play for the answers. That's going to be 60 and 75. That's 2 times 2 times 3 times 5. And that's 3 times 5 times 5. And HCF, so the matching pairs, no, that's not a matching pair actually. It's 3 and 3, 5 and 5, so it's actually 15. So that's going to be 3 times 5, which is equal to 15. And for the LCM, we're going to do the HCF, which is 15, and we're going to multiply that by all the remaining numbers. and that gives us 300. So press pause and have a go at these practice questions. When you're ready for the answer, press play. Here are the answers. Mark your work. Hopefully you found this video useful, and as always, I'll catch you in the next one.